In the previous session, we have worked out the problems in exercise 3.2, 3.3 of trigonometry. Up to 5 problems we did it. And from 6th problem onwards, we'll be doing that. And we will have to see the multiple and submultiple angles next. Using two formulae, sine of a plus b and cos of a plus b, I derived the formula up to, I think if I remember well, up to 18 formulae. Like using sine of a plus b, cos of a plus b, replacing b with minus b, and adding them, subtracting them, multiplying them, and dividing them, we have reached up to maybe formula number 16 or 17 or 18, something like that. And after that, multiple and submultiple angles we have to do. That is, multiple and submultiple angles means we will replace b with a in sine of a plus b, so that we will be getting sine of a plus a, sine 2a. And similarly, cos of a plus b becomes cos of a plus a, cos 2a, and all this we will be seeing in the next part of it. But before that, let us understand the graphs of trigonometric functions, which is very, very important part for the objective questions particularly. So always understand the graph of any function is very, very important because it gives you the entire structure of the function. What I mean to say by structure of the function, where it is increasing, where it is decreasing, where it is taking a turn, what is its maximum value, what is its minimum value, and all this you will be knowing. What is the period of the function? What is the period of the trigonometric function, particularly because we are discussing trigonometry here, and all these will be clearly known if you see the graph of any function. So particularly to upgrade yourself to the objective examinations, knowing the graphs of different functions, mathematical functions, is very, very important part. So here today, let us see the different trigonometric functions graphs. That is the sine x, cos x, tan x, cot x, secant x, and cosecant x. But before that, you must always be clear about the domain and range of the functions. First of all, what is the domain of the function and what is the range of the function? See, domain of the function is nothing but the input whatever you give to the function. Input whatever you give to the function. Even in your further after you enter into your engineering courses, higher level courses, this domain is said to be input. Say an input, and the range is said to be output. For example, the room in which you are sitting is electrified. Electrified means if you switch on the bulb, then what happens? The light comes out. The light comes out. So your input is electricity and the output is light. So input is nothing but the domain and output is nothing but the range. So knowing the domains and range of the functions eases you to draw the graph of any function. So basically to draw the graph of any function, it is inevitable that you must know the domain and ranges of the functions. So let us see now the domain and range of functions. Okay, so here if you see, I think I already gave you the domains and ranges of the function, isn't it? The trigonometric function, did I?
No, sir.
Okay, no worries. Let us see that. Let us see that, and you will have more clarity. You will have more clarity if I explain you the domains and ranges of the functions. And if you remember domains and ranges of trigonometric functions, graph is easy to understand. But before that, what is the domain and what is the range? If you take any mathematical function, for example, y is equal to f of x, if you take, whatever the value you give to the function is nothing but the domain. Remember. So domain is nothing but the value of x, and whatever the value you get from the function by giving a value to x is nothing but simply the range of the function. So always remember, domain is denoted by x and range is denoted by y. This is what you have to understand. For example, if I take y is equal to sine x. And as far as you know, I can give x value 30 degrees, 0 degrees, 45 degrees, 60 degrees, 90 degrees, 120 degrees, 1080 degrees, and minus 2000 degrees, or whatever the value you give, it accepts. It accepts, because we have seen allied angles. Allied angles, in the allied angles, this x accepts every value. X accepts every value for sine particularly. But whatever the value you get by giving some values to x, always lies between -1 plus 1. Very, very important point, please. Very, very important point. That means the visibility of range, it lies on y-axis, and the visibility of x lies on the x-axis. So x-axis gives you the domain of the function, and if you see any graph of any function, if you see graph of any function, on x-axis its expansion gives you the domain, on y-axis its expansion gives you the range. Okay. So because y is lying between -1 plus 1, so this graph of sine x always lies between -1 plus 1 on the graph. So what happens? Every value of x, whatever the value you give to x for sine x, all those values lies between -1 plus 1 only. -1 plus 1 only. That is the reason why this graph is very much visible, and hence it is used in medical equipments and all. The medical, because it's a continuous function. In the medical equipment, whatever the pulse rating is there and the heart beating is there, and all these are continuous functions of our body. So continuous functions of our body is to be linked up to a continuous function mathematically. So sine x is a continuous function, and hence whatever the waves you see on the oscilloscope and all in the medical equipments, they're all sine waves only. Sine waves in the different forms. So overall, what is that you have to understand? Domain is the input. And what is range? Do you respond? What is range?
Output.
Output. Simple. So we are now understanding for all the trigonometric functions, the input and output. So let us understand that. Okay. So here, let me take a table to show you the domain and range of different trigonometric functions. Okay, so as you know, there are 6 different trigonometric functions. Among them, the number one is sine x. So this is the function. I'll do one thing. I'll take the similar graphs of the functions first, and then we will see all the similar graphs first, and then we will move on to the second part of it. That is what I mean to say. Just a moment. I'll take up first sine x and cos x. The reason you'll understand now. So first, sine x, and then cos x, because both are very much similar with a small difference, slight difference. I'll be writing domain here. I'll be writing the range here. Just understand carefully. That is, first function. y is equal to sine x. And second function is y is equal to cos x. If you see these two functions, sine x and cos x are similar. You have the similar nature for these two. That is why I am taking them as pair. This is domain and this is range. So if you take the domain of this function, it accepts every real number. That is the beauty of this function. It accepts every real number. And here also, it accepts every real number. What does it mean by every real number? Minus infinity to plus infinity. But the beauty here, whatever the value they accept, it always lies between minus 1 and plus 1. That means, what is that you have to understand? Domain is nothing but the value of x, and range is nothing but the value of y. So, here, it is common sense, Maurya. It is common sense that if you take sine x, sine x is adjacent side by hypotenuse. You tell me whether hypotenuse will be greater or adjacent side be, sine x is nothing but opposite side by hypotenuse. And you tell me whether opposite side is greater or hypotenuse is greater.
Definitely the hypotenuse.
Obviously, hypotenuse greater, and hence the value will never exceed 1. That is an important point to be honest. And hence the value will never exceed 1, and it will not go below minus 1. So these are the 2 points to be remembered. Now let us see the graph of it. Let us see the graph of it. See, unlike your lower classes, you will not be given any graph sheet in your 11th and 12th. Important point to be remembered. You will not be given any graph sheet to draw the graph in 11th and 12th. You will have to show the rough diagram of it. That means knowing the basic shape of the function is very, very important. Knowing the basic shape of the function is very, very important. So here, if you see, this is 0, this is pi by 2. The known values I'm writing here. This is pi, this is 3 pi by 2. This is 2 pi. This is minus pi by 2. And this is minus pi. And this is minus 3 pi by 2. This is minus 2 pi. Okay. Now let us understand this is plus 1 on y-axis and minus 1. So it is common sense that you must have the graph lying between these 2 points only. You must have the common sense that the graph must lie between minus 1 and plus 1 only. Okay. So let us see that. Let us see that. And you tell me, let me change the color so that you will have more clarity about this. I'll be taking the other color. Now tell me, what is sine 0, please?
Sine 0 is 0.
0. Done. What is sine 90?
Sine 90 is 1.
What is sine 180?
Sine 180 is 0 again.
Sine 270 minus 1. We have learned the allied angles. Allied angles. According to that, sine 270, just revise once. Sine 270 is minus 1. 180 plus 90. Third quadrant. Third quadrant sine is negative. For 180 it won't change. You'll get minus sine 90. Minus sine 90 is minus 1. Similarly, any integral multiple of pi, sine value is 0. Sine 2 pi is 0. Okay, so that is the reason why. That is the reason why if you draw this graph, you will understand why the sine graph is said to be wave. It will form like a wave, sine wave. We call it as sine wave. It will go like this. And similarly, if you mark the points at the other side also, you'll be getting the same. It's a continuous process because its range is lying between -1 and +1. Its range is lying between -1 and +1. So this is the graph of sine function. Okay, it takes the form of a wave, and what is that you can observe? It increases between -pi/2 to +pi/2 like this, and it decreases from pi/2 to 3pi/2. Again increases, again decreases, like that it goes. And whatever the shape is taken by the graph, whatever the interval it repeats, it is said to be period of the function. Whether it is given in your CBSE textbook or not, I don't know, but it is to be known by you, that is the period. What is the meaning of period? Whatever the interval is there, the positive interval, the basic shape of the graph is between 0 and 2 pi. The same shape is repeated between 2 pi and 4 pi. The same shape is repeated between 2 pi and 4 pi. Like this. Okay, so 0 to 2 pi, whatever the shape is there, 2 pi to 4 pi, the same shape will be there, 4 pi to 6 pi, the same shape will be there. So it is periodically repeating whatever the shape is in between. So 0 to 2 pi. So the period, even though it is not given in your, I think, in your CBSE textbook. So fundamental period, we call it as fundamental period. Very simple, don't think more about that. I'll tell you like this. If you take day and night are generally taken as periodic, and period is equal to 12 hours. If you take 1 day, period is equal to 24 hours. If you take 1 week, period is equal to 7 days.
7 inches.
If you take 1 month, period is 30 days average. You're asking doctor?
Yes, sir. Yes, sir.
Yeah.
Constant repetition.
Periodically repeated. If you take moon, the period is, moon also increases and decreases. Period is 14 days, in fact. Whatever the lunar calendar is there, that is English calendar, is not perfect. According to the Indian calendar, there are 28 phases will be there for moon, in fact. So 14 days is a period of the moon. And if you take a year, the period is equal to 365 days. If you take a leap year,
366.
4 years. 366 days is different. Repetition is important. Leap year repeats for 4 years. So repetition, the basic repetition is said to be periodic function. So if you take leap year, period is equal to 4 years. If you take a cyclone, not periodic. If you take a tsunami, not periodic. If you take whatever the cyclones happens, even in the deserts also, they are not periodic. It's not known to the humans. It is known to the humans, no one will believe God, I say. So what God has done, He has kept some functions in His hands and He creates calamities. In fact, that's my feeling, what I'm saying. So some of the functions in the universe are periodic and some are not. Similar is the case with mathematics also. Not all the functions are periodic. Only few functions are periodic. So periodicity means the repetition of the graph, the least positive value of the repetition of the graph is taken as the period. So in this case, it is 2 pi. So periodic function, whether sine function is periodic or not, yes. Cos function is periodic or not, yes. They are periodic. Then what makes the difference between the sine function and the cosine function? You tell me what is cos 0, this is y is equal to sine x, is yellow color is y is equal to sine x. And what is cos 0? 1. What is
One.
cos pi by 2? 0. What is
0.
cos pi? Minus 1.
1 minus 1. Then
What
again
is cos 3 pi by 2? 0. What
Again
is
0.
cos 2 pi?
1.
What is cos 5 pi by 2? 0.
0
What is
minus 1.
cos? So the same function cosine is very much, graph is very much similar to sine only. But the difference is
It starts with 1.
sine function passes through origin, whereas cos function does not. Cos function does not pass through the origin. That is what the difference here. So, but the periodically they are same. But cos is not preferred by the in the usage. Cos is not preferred in the usage because it will not pass through origin of reference. But sine graph is passing through origin of reference. It is easy to count from the origin. That is the reason why cos graph is not used, even though it is very much similar to the sine function. So this is what about the sine graph and cos graph. Let us see what are the shapes given there in your textbook. Okay. So what are the things to be remembered here? Sine x domain set of real numbers and cos x domain set of real numbers, and range is also same -1 to +1, and it is also -1 to +1. So let us check. Let us check your CBSE textbook here. Just a moment. Just see the cos graph here. Sine graph, first one. Sine graph, you can see. The shape of the graph is in the form of a wave. It is in the form of a wave. It is also in the form of a wave. That is why we call it as a sine wave. And it is preferred because it passes through origin. But it is not passing through origin. So that is the reason why it is preferred. That is about sine x and cos x. Okay. The higher level, we will be learning the periods and all for the board examination. I don't think that is given, but the period part is very important for the objective examinations. Next, we will go through, this is sine x and this is cos x. Next, we will go through the tan x and cot x. Tan x and cot x. Let us see now. This is, I hope you understand more clearly. He has not mentioned particularly the domain and range of the function, which is very important. Okay, now let me move to the next part of it, that is tan x and cot x, the graphs of tan x and cot x. So basically, what is that to be understood? The domain means you have to give such values to the function which are acceptable to the function. The values that are not acceptable to the function should be avoided. There is no such case in sine and cos, but it is there in tan and cot. Why is it so? Because if you write tan x and cot x, this is tan x, this is cot x. Tan x is Sine x upon cos x. Follow this carefully. Sine x upon cos x. When you have this, there is every possibility of cos x becoming 0. If cos x becomes 0, what happens, this will be undefined. This will be undefined. Though in that case, you should not have cos x becoming 0. You tell me, for what value of x, cos becomes 0?
Pi by 2.
That's good. And you have to understand that for every odd multiple of pi by 2, it becomes 0. If you see the graph of it. For every odd multiple of pi by 2, it becomes 0. I'll show you that for your better understanding. I'll show you that. See the graph, I'll show you whatever the graph is given here. Just see this. Pi by 2, it is 0. 3 pi by 2, it is 0. And 5 pi by 2, I'll erase this. Just a moment. Just check it out. This is 3 pi by 2 here, 0. 3 pi by 2 here, 0. And 5 pi by 2 here, 0. 7 pi by 2 here, 0. So for all odd multiples of pi by 2, the cos function becomes 0. So you should not have this value for tan. If it is 0, it is not defined, and hence those values are to be avoided. Those values are to be avoided where it becomes 0. Which one becomes 0? Denominator becomes 0. And hence, it is to be understood like this. It is to be understood like this. You can give any real value. You can give any real value to this, but some values are to be avoided. That's a very important point to be understood. You give any value, whatever you like, but some are to be avoided. That is r minus x such that x is equal to 2n plus 1 into pi by 2. N belongs to Z. N belongs to Z means it is an integer. Any integer. Follow this carefully, please. What is that I did? R minus I wrote. Don't forget that. See carefully. R minus means you give any real number, but you don't give these values. What are those values? For all odd multiples of pi by 2, you should not give. I'll say it as n belongs to I or n belongs to Z. Whatever. Okay. So, now what about the range? Range will be any set of real numbers. It takes every real number. Because if you see the tan values now, tan pi by 2 plus infinity, tan of minus pi by 2 minus infinity. That means it gives you all the values. Right, tan 0, 0, tan 30, 1 by root 3, tan 45, 1, tan 60, root 3, tan 90, undefined. Similarly, tan of minus 90, also undefined. That means it ranges from minus undefined to plus undefined. Generally, infinity terms are to be used in the limiting conditions in calculus. We should not use them as infinity, but we must say it as undefined. So that is the reason why it takes all the set of real numbers. That means range contains all the set of real numbers. Now, let me expect the domain of cortex from you. I'm erasing this to give you a better idea. No, the idea I want from you. If you understand properly that tan x domain, you can say cortex domain now. What is cortex in terms of sine and cos?
Cos by sine.
Yeah, cos x by sine. Come on, tell me what should not happen.
Sine x, in sine x, x should not be, sine x should not be equal to 0. That is, x should not be 0 degrees, pi, or any or n into pi.
Very good. Very good. Come on, tell me now, what should I write in place of the domain of coordinates?
R
Minus, this is a set notation, x is such that, you have to read it as x is such that.
okay, x such that x is equal to n into pi by 2. N into pi, n belongs to I.
Any integer. You send out this word, this is what I wrote, this is a general form. What should be the range of it?
The range also same. Yeah, same.
Set of real numbers. Set of real numbers. Okay? So, this is what you have to understand. And there is a break here in the domain. That means x-axis will contain breaks in the graph, unlike sin x and cos x. Unlike sin x and cos x, x-axis will have breaks here. So that's the reason why this graph is not continuous for the set of real numbers, and hence you have to show the breaks in the graph. Let us see how it will be. See. And you can see very clearly that when you are not giving pi by 2 minus pi by 2 for this function tan x, minus pi by 2 plus pi by 2 for this function tan x, then how do we show that in the graph? Understand, in the graph, it will be shown as a vertical line. Why? Further, you'll be learning vertical line slope in geometry is said to be undefined. Undefined. Slope concept, I think you might have got in your lower classes. Did you? In straight line?
Kind of, sir.
Yeah, not completely. So, if you take this as y-axis, this will be negative y-axis. And how to show pi by 2 and minus pi by 2 here, line, this line represents plus pi by 2. Similarly, this line represents minus pi by 2. Okay, so the graph I want to show you, tan of minus pi by 2 is negative undefined. Tan of pi by 2 is positive undefined. Tan 0 is 0, you know. Tan 45, half of it will be plus 1. And tan of minus 45, half of it, minus 1. I think you must be remembering. Tan 45 is 1.
Yes, sir.
So, only these points we know. And the rest of the points also we know. For 60, we know root 3 will be there. For minus 60, minus root 3 will be there. So, the graph of it will go like this. This will be shown parallel to x-axis. Because generally, why we use them parallel? Two parallel lines will never intersect each other. But mathematician says they intersect at infinity. Because infinity is not known to us. Infinity is not known to us. That is why they are shown as parallel lines in the graph. Like this. So, this is tan x graph. Similarly, this is the first part. How the second part will be? Very much similar, and it will be parallel. Very much similar, and it will be parallel. At what points it is to be shown parallel? For all odd multiples of pi by 2, it should be shown parallel. So here, pi by 2 is there. Next one is pi, and next one will be 3 pi by 2. So the graph will be then very much parallel to this, like this, goes like this. And this part here you will have one more. I'm not drawing the lines there, this will understand. That is the reason why this tan x is said to be discontinuous function over the set of real numbers, because it does not accept some x values. It does not accept some x values. That is the reason why it is said to be discontinuous functions. But you can see that for all values it is always an increasing function. As x increases, y is also increasing. As x is increasing, y is also increasing. That is the reason why tan x is said to be the continuous over the interval open minus pi by 2 to plus pi by 2 open. That means in between it is continuous. In between it is continuous, but over the set of real numbers it is discontinuous, because it is discontinuous at pi by 2 minus pi by 2, 3 pi by 2 minus 3 pi by 2. So, but it is continuously increasing. Continuously increasing. Increasing means x value increases, y also increases. You can check it out by the values. Tan 0, 0, tan 30, 1 by root 3, tan 45, 1, tan 60, root 3, tan 90, undefined. As x increases, y also increases. That is said to be increasing function. Now let us see what happens to tan in this case. What happens to tan in this case? Let us check that. Now tell me, what is cot 0?
Cot 0 is 1. I mean, undefined.
Undefined. What is cot pi by 2?
Cot pi by 2 is also, cot pi by 2 is 0, 0, sir.
0, 0. You're right. So, similarly, cot pi is undefined. Just observe what happens. I'll ask you like this. Cot 0, undefined. Cot 30, root 3. Cot 30, root 3. Cot 45, 1. Cot 60, 1 by root 3.
Cot 60.
Cot 90,
Cot 2.
0. What is that happening? X is increasing. Angle is increasing, value is getting decreased. So that is why it is just like a mirror image. Cot graph, because cot 0 is said undefined, and you have to make it parallel here. You have to make it parallel here. Okay, so what happens? It will be just like this. Cot graph. You see? The mirror image.
Yes.
Similarly, what should be the second part? It goes like this. Very much parallel. It goes like this. Similarly, this one. It goes like this. It goes. Do you understand? Now what is
Yes,
that
sir, yes, sir.
happening? As x is increasing, y is getting decreased. Just observe that. As x is increasing, y is getting decreased. So cot is a decreasing function. So if they are in the opposite direction, x increases, y decreases. X decreases, y increases. Then it is said to be decreasing function. The graph also is clearly seen. The graph also is clearly seen. X is increasing, y is getting decreased. It is said to be decreasing function. Further, in calculus, after learning calculus, we will have the application of this increasing and decreasing functions. It's a very good topic. Further, you will have to know that even in physics also you have the applications of it. So this is about tan x and cot x. I have shown in the same figure. Okay, I hope you understand that. And what is the domain of tan x? Just read it out once. We'll move on to the next part of it.
R minus x such that x is equal to 2n plus 1 into pi by 2 n belongs to I. Range of tan x is equal to R. That is any real number. For cortex, domain is R minus x such that x is equal to n pi. N belongs to I. Range is any real number.
That's good. So let us see what is that given in your textbook. Yeah, say this. Check it out. See, for it is tan x, please, tan x. This is pi by 2. It is shown parallel, just see this. It's shown parallel. For minus pi by 2, it is shown parallel like this. And second part, pi by 2 to 3 pi by 2. Very much parallel to the first graph only. Similarly, it goes continuously. Why the division is happening, you tell me? Unlike the sine and cos functions, why the division is happening?
Because for certain values, the denominator is 0.
That means it becomes discontinuous there. It becomes discontinuous. You don't accept those values and they have to be eliminated from the domain. Similarly, cot x is exactly the mirror image of tan x, and of course it is also reciprocal of tan x. Just you can compare it, and here cot 0 is undefined and hence the graph is in the decreasing form. It is in the decreasing form. It's always increasing, it is always decreasing. Okay, I hope you understand that. Yeah, let's move on to the next and final part of it is the reciprocals of sine x and cos x. What are the reciprocals of sine x and cos x, please?
For sine x, it's cosec, and for cos x, it's sec.
Yes. So, can you imagine? Now, if you understand my explanation about the domain of tan x, if you understand my explanation in finding the domain of tan x, you can say the domain of secant x very easily. The logic what I explained you in finding the domain of tan x, if you understand that properly, you can say the domain of secant x and even cosecant x straight. Like what? Let me change this. This is secant x. Let me change this. This is cosecant x. Let complete cosecant x. What is the logic I applied to find out the domain of tan x, please?
Such that the lower value denominator doesn't come 0.
Yes. What is the denominator of tan x?
Tan x denominator is sine x, cos x.
Correct. What is the denominator of secant x?
Secant x denominator is cos.
That's it. That's it. But I forgot to tell you the fundamental period of tan and cot is pi. Fundamental period of tan and cot is pi only, because in the interval of pi it repeats. Anyway, I have to take that class separately for the objective examinations because it is not given in your board level. I will be taking that separately. But now do you understand what I'm saying? The denominator of tan x is cos x. The denominator of secant x is also cos x. So that's the reason why.
So same rule.
That's all. The same domain you will have. Similarly, what is the denominator of cot x?
Cot x is sine.
Sine. What is the denominator of cosecant x?
Also sine.
Correct. That is the reason why domains are same for this. Okay. Now, one more hint here for you. Whose reciprocal is secant x?
Cos x.
Cos x. What is the range of cos x?
The range of cos x is 1 to minus 1.
You must say the lower value first.
Okay, minus 1.
Minus 1 to plus 1. Whose reciprocal is cosecant x?
Cosecant also sine x.
Right. What is the range of sine x and cos x?
Same, -1 to +1.
Very good. Because they lie between minus 1 plus 1, their reciprocals will never lie between minus 1 plus 1. Very simple understanding and easy to remember also. Their reciprocals never lie between minus 1 plus 1. That means they are a very simple understanding, Maurya. Like if you say, for example, sine x is 2 by 3, for example. What is cosecant x?
3 by 2.
That means it is greater than 1. It is less than 1, its reciprocal will be obviously greater than 1. So whatever the values are there for that, that will not be there for its reciprocal. And you can, I want to show you in a different format also. The different format means, for the better understanding, let me show you the other form of this, other form of writing this r minus 1 to r minus of minus 1 to 1. R minus of minus 1 to 1 can be written like this. Set of real numbers means minus infinity to plus infinity. So this can also be written as minus infinity to minus 1. Or minus infinity is always unknown to us. That is why you have to open it. But it accepts minus 1. Union 1 to infinity. It is read as union. You will be knowing that further in sets and relations. You will be knowing that union means r over r. Or r, either this value or this value, never in between. Never in between. Either it takes this value or this value, never in between. Both are same. Both are same. Okay, that's the reason why. What happens, in the graph of this secant x and cosecant x never lie between minus 1 plus 1. Important point to be noted. They never lie between minus 1 plus 1. That means the graph should either be more than 1 or it should be less than minus 1. Very important point, please. Very important point. And the discontinuity obviously happens just like tan only. Discontinuity happens just like tan only for secant x, because you know the reason. I need not to tell you that, because both the denominators are cos x. For tan x and secant x, the denominators are cos x only, and hence the discontinuity for these two same. So similarly, whatever the discontinuity is there for cot is same for what?
Tan.
I repeat, whatever the discontinuity is there.
Cosec.
Yes. Now, let me show you that. I'll mark the values now. This is 0. This is pi by 2. This is pi. This is 3 pi by 2. And this is minus pi by 2. This is minus pi. Okay. Now, you tell me the range of secant x and cosecant x, please.
Range of secant x is r minus of minus 1, comma 1.
So this is to be opened because it accepts. We are subtracting it here. We have to open it. If you close it now, what happens? This value also will be eliminated. Because we are subtracting, we should not subtract those values, it is accepting. Okay, so it is plus 1 and it is minus 1. Your graph should never lie between minus 1
1 and minus 1.
What is secant 0, please?
Secant 0 is 1. 0. Secant 0 is 0 by 1. Not defined. Wait, 0.
What is secant 0 converted to cos?
Cos 0 is 1. Secant 0 is 0. One.
So this is 1. So that means it starts at 1. What is secant pi by 2? 1 by cos pi by 2. 1 by
That's 0 by 1.
Similarly, what is secant of minus pi by 2?
Minus pi by 2 is also same.
So what happens now? It will come like a bowl above 1. It will come like a bowl above 1. And the next bowl will be here. Secant pi minus 1. And next bowl will be like this. This is the graph of secant x. You need not have to draw the exact graphs in 11th and 12th. Even in the entrance examinations also. You must know the basic shape of the graph because you will have to understand its maximum value, minimum value, where it is increasing, where it is decreasing, where it is taking a turn, and all this you must know. So this is secant x graph. Okay? Now, can you imagine now how the graph of cosecant x will be?
Reverse.
It will be just shifted to pi by 2. That's it. The same graph will be shifted to pi by 2. What is cosecant pi by 2? 1 by sine pi by 2. What is sine pi by 2? 1. So 1 by 1, you will get 1 here. For cosecant, I am talking about this function, cosecant pi by 2. 1 by sine pi by 2. What is sine pi by 2? 1. So 1 by 1, 1. What is cosecant 0? 1 by sine 0. What is 1 by sine 0? 1 by 0. 1 by 0 is what? Undefined. Similarly, cosecant pi also undefined. So these undefined cases will be shown like this. Check it out, please. Check it out. If you observe carefully, even for sin x and cos x also, there is a shift of pi by 2 in the graphs. Here also, there is a shift of pi by 2. This is pi by 2. This one is shifted to pi by 2 interval in x. So, one is above. What should be the other one then? Do you tell me?
Before, little further.
Below or above?
Below.
Why? It should not lie between?
Minus 1 and plus 1.
Plus. Now, so coming to the next part of it, this will go like this. That's it, please. This is about secant x and cosecant x graphs. Okay. In the advanced level, higher level, what we will be doing, we'll be understanding further for the objective examinations, sin x, sin 2x, sin 3x, sin x by 2, cos x by 2, cos x by 3, tan x, tan 2x, and for all the multiples also, we will be understanding further. We'll be understanding further, and that is for the higher level, for the objective level, we'll be understanding that. But till then, this is, as far as your board is concerned, these are the graphs. Based on this, we can extend these graphs even to, we have seen sin x, cos x, tan x, cot x, secant x, and cosecant x. But based on this, we can even extend them to other multiples also. Other multiples, what I mean to say, x, 2x, x by 2, x by 3, and all this. Just see the graph of secant x. This is the form of a bowl like this. One above, one below. One above, one below. Why is it so? They must not lie between minus 1 plus 1.
Minus 1 and...
So, an objective question is given like this. For example, secant x is equal to 3 by 4. If I give you this, immediately you have to say, is not possible.
Not possible because it is below, it lies between minus 1.
It does not. Otherwise, it is common sense that cos x is 4 by 3. How is it possible? It is greater than 1. Does not belong to minus 1 plus 1 because range must lie between minus 1 plus 1. It's not possible. So secant x 3 by 4 given, immediately you have to understand that it is not possible. In the objective examinations, you'll be given such questions to confuse you. That is the reason why you must understand the domains and the ranges of the functions. This is what the 6 graphs of different trigonometric functions. In the higher level, I'll be teaching you that for the objective examinations, the higher level graphs, how it will be. And back before that, let me show you different graphs at a time. At a time, what I mean to say by at a time, I have collected some images which can be seen here. Just I'm just discontinuing the share now. Just see the images here. This is inverse trigonometry functions. Not now. You have this inverse, I think, in your 12th class. Not now. But just recognize which functions these are.
This is the recent one, sec and cosec.
I'll pin the image. Just a moment. Just a moment. I'll pin the image now. Now you talk. You tell me which graph it is. Just at a glance, you have to tell
This
me.
one, sine.
No.
Wait, it starts at 1, so it's a cos.
Yes. This one?
This one, cot.
Of course, it is mentioned there, but you have to understand. And this one is, further you'll be getting this, it is a sine square x graph, sine square x, not sine x. At a higher level, we'll be learning this. Similarly, this is mod x plus mod cos x. At the higher level, we'll be learning all this. For your board examination, I don't think these are not for you. And you can see sine x, sine x blue color, sine 2x, this one pink color, and sine x by 2. How the graphs will be, I'll show you that whenever it comes. Just a moment. It is given in the. Now, you recognize the graphs. What is a blue color graph?
It's given.
And cos, and that one is sine like that. Now, all are together. This is tan x, and this is sine x and cos x like that. The graphs are mixed here. Okay. Now, the important thing you have to remember is that I'll show you that separately. Just a moment. Just go through seeing those graphs. I'll be opening this graphs. What happens to sine 2x graph and what happens to sine x by 2 graph? That's what I like to discuss. Simple. We'll close with this. That is, if you take sine x graph and if you take sine 2x graph and if you take sine x by 2 graph, how will it be? Just a moment. I'm sharing the screen. Just you'll understand that. See. Just check it out. Check it out, please. You tell me which color is denoting sine x blue color. Which color is denoting sine 2x pink color? Which color is denoting sine x by 2, maybe brown color?
Brown.
What is your observation in the graph? Just tell me.
All start from 0 except
Very
pink.
good.
That's
Very good.
sine 2x.
That's okay. And if you take the first primary curve, that is the period, for sine x it is 0 to 2 pi, it is taking the first shape. But sine 2x, just observe, it is taking the primary shape between 0 and pi only. Primary shape it is taking between 0 and pi only. So, the important thing to be noticed is that sine x graph, sine 2x graph, if you compare now, sine 2x graph will be half of sine x graph. Remember that. Sine reverse. Sine x graph will be half of sine 2x graph. Then observe sine x by 2 and tell me.
Twice of sine x graph.
Yes, that's what it is. So that's the reason why the periods differ like this. Further, in the advanced level, we'll be learning this. Period of sine x function is, what is the period of sine x function? I said 2 pi, no?
Yes, sir.
The period of sine x function is 2 pi because I said whatever the shape is there between 0 and 2 pi is getting repeated. Periodically it is repeating, that is why its period is 2 pi. But what is the period of sine 2x? You tell me.
Sine 2x, it's pi.
Pi. So what happens now, whatever the coefficient is there for x, you have to divide the primary period, the fundamental period with that coefficient. So 2 pi by 2 gives you pi. Then if you observe sine x by 2, you know, sine x by
4 pi.
Ah, that's good. So 2 pi divided by 1 by 2, it is 4 pi. Like this it will be. And you will have the higher level questions, particularly based on this periodicity. We'll be learning further. And in the objectives, we'll be learning that. As far as your board syllabus is concerned, that is sufficient for us. Okay. So in the next session, we will be doing the problems, and whenever we get multiple and submultiple angles in the problems of, I think, exercise 3.3, no? Exercise 3.3. And in that one, we'll need the multiple and submultiple angles. Then, and there itself, I'll derive the formula of multiple and submultiple angles. Okay?
Okay, sir.
See you, Maurya. Good night.
Yes, sir. Night, sir.